Hi, welcome you all for the presentation on pigments and flavors. Present lecture is divided into two sections, pigments and flavors. Let us see one by one. Pigments are used for coloring food, paint, ink, plastic, fabric, cosmetics and other materials. Most pigments used in manufacturing and the visual arts are dry colorants which grind into a fine powder. The term pigment is used for coloring products such as food products, beverages, textiles and pharmaceutical products. Pigments produce the colors that we observe at each step of our lives. Because pigments are present in each one of the organisms in the world and the plants are the principal producers. They are in leaves, fruits, vegetables and flowers. Also, they are present in animal skin, eyes, bacteria and fungi. Pigments are chemical compounds that absorb light in the wavelength range of the visible region. Produced colors is due to a molecule specific structure. This structure captures the energy and the excitation of electron from an external orbital to a higher orbital is produced. The additional pigments into food products for one or more of the following many reasons: to replace color lost during food processing, to provide the original shade color of many fruits in enhanced color already present, to minimize batches, particularly berries, example strawberries, elderberries, and to color the food otherwise uncolored one are not attracted by buyers. In today's world, there is a large number of pigments available. In fact, after the advent of synthetic pigments, there has evolved various class of pigments that are suited to particular types of industries. Natural pigments are produced by living organisms such as plants, animals, fungi and microorganisms. Moreover, natural pigments further classified by their structural characteristics as following groups: tetrapyrrole derivatives, chlorophylls, hemyls and billins; isoprenide derivatives, carotenoid and iridoids; N-heterocyclic compounds different from tetrapyrroles, purines, petrins, flavins, phenozoins, phenoxazines and beta-alanines; benzofuran derivatives, oxygenated heterocyclic compounds, anthocyanins and flavonoids; quinones, benzoquinones, naphthoquinones, anthraquinones, melanins; artifacts, melanoids, caramels. For example, hemoglobin is the blood pigment and also in cytochromes, peroxidase, catalysis and vitamin B12 as prosthetic group, all of them with a wide distribution. Plant porphyrins consist of chlorophylls, also called as the green pigments, that are ubiquitous in nature since they are responsible for the photosynthetic process. In spite of their abundance, however, it is primarily plants such as alfalfa, nettle and leaves of carrot which are used as a source of these colorants. The carotenoid are probably the best known of the food colorants and certainly they are one of the largest groups of pigments produced in nature. Carotenoids lipid soluble compounds responsible for yellow and red color of plants and animal products which absorbed in between 430 to 480 nanometer. Organic pigments are chemically synthesized as they are not found in nature. They contain carbon and comes with relatively low levels of toxicity, not providing any major environmental concern. Raw materials can include coal tar and petroleum distillates that are transformed into insoluble precipitate. They are used as a moss colorants and are popular in plastics, synthetic fibers, and as a surface coating paints and synthetic colors or man-made colors appearance in an important goal in the food industry. Organic pigments are generally categorized into 6 types: diazopigments, monoazopigments, acid and base dye pigments, phthalocyanine pigments, other polycyclic pigments, quinacridone pigments. Inorganic pigments are created through chemical manufacturing rather than by grinding and washing clays or minerals taken directly from the earth. The preparation process is also simple and consists of the steps of washing, drying, pulverizing and mixing into the formulation. They are metallic oxides of synthetics. The following examples are very popular class of inorganic pigments: titanium oxide, rutile and anatase, antimony oxide, zinc oxide, calcium carbonate, fumate silica. Fewer other examples of inorganic pigments: lead oxides, cobalt blue, chromium oxide, cadmium yellow, molybdate orange and nickel titanate. As new environmental laws are very strict about toxicity, a few of these heavy metal pigments are no longer in use. Natural and synthetic pigments are used in medicines, foods, clothes, furniture, cosmetics and in other products. Overall, natural pigments used as food colorants are good colorants in a wide color spectrum and a source of healthy components in many food products. These healthy properties are mostly due to antioxidant activity, and the opportunity to make functional food based on natural pigment is potential. Some natural pigments are already used in pharmacological products such as anti-inflammatory, anti-cancer, etc. Flavor is the sensory impression of a food or other substance and is determined mainly by the chemical senses of taste and smell. Flavorant is defined as a substance that gives another substance of flavor, altering the characteristics of the solute, causing it to become sweet, sour, tangy, etc. Of the 3 chemical senses, smell is the main determinant of food items' flavor. While there are only 5 universally recognized basic tastes: sweet, sour, bitter, salty and umami. It means that savory. The number of food smells is unbounded. Historically, there is a little literature in the public domain on food flavors until the mid-1900s. At the beginning of the 1900s, a growing number of food and beverage companies including Kellogg, Campbell Soup, Coca-Cola and Pepsi-Cola created even more demand for commercial flavors. Next, the classification of flavors. There are 3 principal types of flavoring used in foods: natural flavoring substances, which are extracted from vegetable or animal materials and are not further chemically modified or changed. An example is vanilla extract. Nature identical flavorings Substances, those are chemically identical to natural substances but which are obtained by chemical process or by chemical modification of other natural substances. An example is vanillin, which is identical to the vanillin in vanilla but not obtained from vanilla pods. Substances obtained by chemical synthesis are chemical modification of natural substances but which are not present in natural products. Flavors also categorized on the basis of preparation. Flavoring preparation is a product from natural origin but which is not highly purified. For example, concentrated apple juice can be defined as flavoring preparation. Process flavoring are substances that are formed from natural substances upon processing, mainly heating. A common example is caramel, which is produced by heating sugars. A smoke flavoring means a smoke extract used in traditional foodstuffs smoking processes. These are obtained by collecting the smoke into a fluid, which can be applied in a different production process. Due to the high cost or unavailability of natural flavor extracts, most commercial flavorants are nature identical, which means that they are the chemically equivalent of natural flavors but chemically synthesized rather than being extracted from the source material. It has been suggested that artificial flavors may be safer to consume than natural flavors due to the standard of purity and mixture consistency that are enforced either by the company or by law. Certain colors are seen as corresponding to certain odors. Example, red for cherry odor. There is influence of color on odor. Identification. Odor discrimination, odor intensity and odor pleasantness. While salt and sugar can be technically considered as flavorant that enhance salty and sweet taste. Usually, compounds that enhance umami as well as other secondary flavors are considered and referred to as a taste flavorants. Umami or savory flavorants are commonly called taste or flavor enhancers are largely based on amino acids and nucleotides. Umami flavorants recognized and approved by European Union include glutamic acid, glycine salt, guanilic acid salts, ionosinic acid salts, and 5-ribonucleotide salts. Certain organic and inorganic acids can be used to enhance sour taste, but like salt and sugars, these are usually not considered and regulated as a flavorant under law. Acid descriptions: acetic acid gives vinegar its sour taste and distinctive smell. Ascorbic acid, better known as vitamin C, found in oranges and green peppers and gives a crisp, slightly sour taste. Citric acid, found in citrus fruit and gives them their sour taste. Fumaric acid, not found in fruits, used as a substitute for citric acid and tartaric acid. Lactic acid, found in various milk or fermented products and give them a rich tartness. Malic acid, found in apples and gives them their sour taste. Phosphoric acid, used in all cola drinks to give an acid taste. Tartaric acid, found in grapes and wines and give them a tart taste. A simple process of obtaining flavoring substances from typical extraction process can be seen in coffee preparation. This process involves hot water separating the flavoring substances and flushing them out of the coffee powder. The filter then separates the soluble coffee components from the powder. The same principle of extraction is applied when deriving vanilla extract from vanilla beans. but here use alcohol or supercritical carbon dioxide as a solvent. This technique, also called as supercritical fluid extraction technique, the raw material is packed into stainless steel extraction columns and then dynamic flow of carbon dioxide in liquid form at pressure of 40 to 60 atmospheres in low temperature between 0 to 10 degrees centigrade. In this condition, the liquefied carbon dioxide dissolves the lower molecular weight organic active components of raw materials and leaving behind the higher molecular weight unwanted materials such as heavier fat, waxes, pigments, sugars, starches and tannins. The solution of products in carbon dioxide emerging from the extraction column is passed to sophisticated heat exchanger. This leaves a pure extract of the products which is tapped from the process under pressure, still below ambient temperature. Next method, counter current extraction. Citrus oil in hydrocarbon solvents are continuously fed into a specially designed column containing many compartments, and this complex mixer in which a counter flow of ethanol containing a small amount of water extract the flavor and aroma molecules, leaving the terpenes to emerge from the opposite end of the column. Solvent extraction technique. In solvent extraction technique, organic solvent is the most common and most economically important technique. In this technique, the raw materials are submerged and agitated in a solvent that can dissolve the desired aromatic compounds. Most commonly used solvents for solvent extraction include hexane and dimethyl ether. During solvent extraction, aromatic compounds as well as other hydrophobic soluble substances such as wax and pigments are also obtained. The extract is then subjected to vacuum processing, which removes the solvent for reuse. The solvent is then removed by a lower temperature distillation process and reclaimed for reuse. Another method, distillation process. The technique is based on the fact that many substances have different boiling points. During distillation, liquid mixtures are separated by heating and distillation process, is the plant or animal sources. Materials being brought in a certain predetermined boiling point. The steam is collected by cooling. In flavoring production, generally in industries, it is used to produce natural citral from lemongrass oil. For example, vacuum distillation is one of the simple techniques for the concentration of essential oils before molecular distillation. The raw material or crude oil is heated under vacuum at precisely controlled temperatures, turning the components into vapors, which is then cooled and condensed to a purified liquid products. Molecular distillation. This distillation technique employs the material to heat for a briefest possible time, while at the same time allowing a very high vacuum to be achieved, which lowers the vaporizing temperature, contributing further to the limited exposure to heat. It allows a continuous feed of liquid to enter and pass down the inside of heated jacket, wiped into a thin film by the centrifugal force of rotating rollers and falling by gravity. Alcohol co-distillation. It involves the addition of pure alcohol to the raw material, which are first treated with water, followed by atmospheric pressure or low vacuum distillation of alcohol, and some water which co-distills the more volatile components to yield the high aroma products. The advantages associated with these type of natural products are clean label, 100% natural, enhanced functionality, product differentiation, and true to nature. Next method, steam distillation. Steam distillation is used as a general term to such products which requires roasting for flavor generation. The method includes wetting the material with moist gas, steaming at varying pressure, and adding hot water, generally used in industries for obtaining coffee flavors. Pigments and flavor components are important to food appearance and taste. Both components can be classified into two categories, natural and synthetic. Natural pigments and flavors can be extracted from plants and animal sources, as well as synthetic pigments and flavors can be synthesized in laboratory. Synthesized pigments and flavors are more safe than natural because of high purity. Natural components may have unwanted side products and it could be toxic on human cells. Thank you.